Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 6 to the power of n plus 36 to the power of n equals to 1260, and we will solve this problem for the real values of n. So the very first thing we are going to do is, here first we will rewrite this equation as, here you have 6 to the power of n plus, we will write this 36 as 6 square and its whole power n, and it is equals to 1260. And here we need to use the nice exponential law, and you know about this law. If we have a to the power of m to the power of n, it is equals to a to the power of n and its whole power m equals to a to the power of m times of n. So here you see that if we will interchange these two exponents, then it cannot be affected our final answer. So here we need to interchange these two exponents only. So now we can interchange these exponents and we will get its output in the form of 6 to the power of n, and plus we write it as 6 to the power of n and its whole square equals to 1260. And now we will convert this nice exponential equation into the quadratic form, so that we will just take here y equals to 6 to the power of n. So when you put or take y equals 6 to the power of n, then this exponential equation will becomes in the form of y plus y squared equals to 1260. So now we will rearrange the terms, and we will make the pairs of this term, and we find the factors of this equation. So that here first we will rearrange the terms and we write it as y squared plus y, and we move this 1260 in the left hand side, and you write 1000 minus 1260, and this whole equation equals to 0. And now here we write this plus y as y squared. Here we write this plus y as 36y and minus 35y, because when you subtract 36 by 35 you will get here y, and when we divide 35 by 1260, then you will get here 36. So that we will find the divisors of 1260, and the divisors of this term are 36 and 35, and we will break the middle term in this form, and we write minus 1060 equals to 0. So now we will easily find the factors of this equation. And now first you focus on the first two terms, and you will see here we have y be the common term, and we take it common, and you get y plus 36, and here we take common minus 35, and we get y plus 36, and this whole equation equals to 0. And now you focus on both of the terms, and you will see that we will just take common y plus 36 on both of the terms, and we get here y minus 35 equals to 0. And now here we have two cases. The first case is we write y plus 36 equals to 0, and the other case is we write y minus 35 equals to 0. So in this case you will get the value of y equals to minus 36, and in this case you get the value of y is 35. So now in the next step we will back substitute the value of y, and you know that in the start of the problem the value of y will be written as 6 to the power of n equals to minus 36, and in this case we have 6 to the power of n equals to 35. So now we can solve these two cases here. Now first we discuss the case number 1, and in case number 1 you see here we have 6 to the power of n equals to minus 36, and you know that in the left hand side we have an exponential function, and in the right hand side we have a negative value, and you know that exponential function always gives the positive value, so it cannot be possible an exponential function equals to some negative value, so that we will rejected this case and we can just proceed here this case only. Now we can find the value of n from this case. Here in we need to find the value of n. So now first I can simplify the terms and we write 6 to the power of n equals to, here we have 35 and we will write it as 7 times of 5 equals to 35, and now we can take the log on both of the sides. So when you take log on both of the sides, it will be looks like in this form, and log of 6 to the power of n equals to log of 7 to the power of 5, 7 times of 5. So now here we use the nice logarithmic properties. So you know that here we use these two properties. The first property is, in this form, if you have log of m to the power of n, it is equals to n times of log m. And the second property which is I can use here is, if you have log of m multiplied by n, it is equals to log of m plus log of n. So here we need to use these two nice properties. So now first I can use the first property in the left hand side. So the exponent will becomes in the form of n times of log 6, and we can take the log on separate on these two terms and we will add these terms and we get log of 7 plus log of 5. And now we can move this log 6 in the right hand side and we will get the value of n equals to log of 7 plus log of 5 and this whole over log of 6. And now you will use the calculator or logarithmic table in order to find the value of log 7, 5 and 6. So you know that the value of log 7 is 0.8450 and the value of log 5 is 0.6989, and similarly the value of log 6 is 0.7781. So when you add the upper two values, then you will get here 1.5439 over 0.7781. So now we will just divide these two values and you will get here this n equals to 1.9841. So this is the our final value of this problem and this is the our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.